So I wanted to show you guys a little handout that I made. I'll be posting this on Teams, but I went ahead and made a table of basic indefinite integrals. And lest you look at this in panic, you know almost all of these in terms of their derivatives. So I've just rewritten them for you. Here I put some of the basic properties. You know, you can pull a constant out, break up over a sum. Integral of a constant is relatively straightforward. Here, the integral of x to the n is x to the n plus 1 over n plus 1 whenever n isn't equal to negative 1. And then did I get that case on here? Yeah. Here's the other case over here. Those really should have been together. The integral of 1 over x dx is ln of absolute value of x plus c, sine, cosine. I went ahead and captured sine of when there's a number involved, like when there's a kx here. It'd be great if you just knew this, because then you don't have to do a U-Substitution. You can just write it down. Same thing. So there's a couple of new things. Integral e to the kx is just e to the kx over k. Everything else, as far as I can tell, are just known derivatives written backwards. For example, you know the derivative of tangent is secant squared, so the integral of secant squared is tangent. Vice versa here, integral of cosecant is minus cotangent. Integral of secant tangent is secant because the derivative of secant is secant tangent, so on and so forth. Here I've got some of the inverse trig functions. I don't think I put down inverse cosine. That one's interesting because inverse cosine just slaps a negative on there. And so, yes, inverse cosine and inverse sine are not too different, right? You can certainly answer, let's write it out actually, minus the integral of minus 1 over root 1 minus x squared dx. You could say this is negative inverse sine plus c, or you could say that's exactly inverse cosine. It doesn't matter to me. So I didn't put it on the list because it doesn't matter. You know, arctangent, inverse sine, sinh cosh, so on and so forth. So again, most of these are things you already know in terms of derivatives, but here's just a couple of ones that are specific that you should put in your back pocket and make sure that you know. So I hope that helps. Maybe let's just end with a couple of quick examples. So if I have the integral of e to the 5x dx, you can do a u-sub, but it's really better if you just know this is e to the 5x over 5 plus c, done. You just divide by that constant. And same if I have the integral of, for example, cosine of 2x, not 2 pi, cosine of 2x dx. This is going to be the sine of 2x over 2 plus c. It's just much faster if you don't have to work through the u-sub process. So file those away in your back pocket. I'll be posting this handout on Teams, and I'll try to put it on Campus Web as well. So, all right. Ciao. We are essentially done. I was just going to do a short lecture series where I'll do 1 or 2 more problems for you that have to do with computing areas. But we are all but done. Great job, you guys. And we'll